Hello, this is Mr. Collier, and today we're doing some right angle trigonometry. So in this triangle here we have 5, 13, and we have x, and we want to find this missing side length, x. And the way we do that is with the Pythagorean theorem. So in a right triangle, the hypotenuse, the hypotenuse squared is always equal to the sum of the squares of the other two sides. So in this equation, the hypotenuse is 13. So we'll have 13 squared equals 5 squared plus x squared, and that's 169 equals 25 plus x squared. Then we can solve for x. 144 equals x squared, x equals root 144, which equals 12. Next example, the hypotenuse is y, so we'll have y squared equals 4 squared plus 3 squared. We'll have y squared equals 16 plus 9, y squared equals 25, y equals root 25, which is 5. So that's how you find missing side lengths of a right triangle. In the next example, this is not a right triangle, so we're not going to be able to use the Pythagorean theorem for this one. We're going to be doing this in a couple of days using some different rules. Okay, so next I'm going to look at this example here, show that a triangle with sides 5, 7, 9 is not a right triangle. So what we have to do here is what we call the converse of the Pythagorean theorem. That is, if c squared equals a squared plus b squared, then it is a right triangle. So if this were a right triangle, what would the hypotenuse be? It would have to be the longest side, which is 9. So it would have to look something like this, and we can test it. Does 9 squared equal 5 squared plus 7 squared? Question mark. So 9 squared is 81, 5 squared is 25, and this is 49. So does 81 equal 74? No. Therefore, it's not a right triangle. Okay, next example. Okay, in the next examples we have a side and an angle. We have a missing side length over here, and we're not going to be able to use the Pythagorean theorem to find these angles and sides. We're going to have to use some trigonometry. So you might remember the acronym SOHCAHTOA. This tells you whether you use sine, cosine, or tangent. Okay? So in the following example, the angle we're talking about here is 15. So x we will consider to be opposite of 15, and 7 kilometers would be adjacent to 15, and this one here is the hypotenuse. The hypotenuse is always the longest side, the side opposite the right angle. So these are the hypotenuses right here. So here we have the two pieces of information we're interested in are opposite and adjacent. So you check your SOHCAHTOA, opposite and adjacent, we use tangent. So I'll set the ratio, tangent, or tan of 15 degrees equals x out of 7. Then you just need to solve for x. I'll multiply by 7, and you get x equals 7 tan 15 degrees. Okay, so we're going to use approximately equal to sign, because I'm going to use my calculator now, and then round the answer to 3 significant figures. So we have 7 tan 15, which equals 1.88. So it's approximately 1.88 kilometers. Okay, next example. We have the hypotenuse already labeled, and we're looking at the angle y. So this one here is opposite over here. This one's adjacent, so we're interested in adjacent hypotenuse. That would be cosine. So cosine of y equals adjacent divided by hypotenuse, which is 4 out of 12. Okay, so then, well, that equals also a third, if you like. So to solve for y, we need to do the opposite of, or the inverse operation of cosine, which is inverse cosine. So y equals inverse cosine of 1/3. Okay, I'm going to do that on the calculator. So I press second function, cosine, and 1 divided by 3. And we get 70.5, about 70.5 degrees. Okay, in the last example, we have the hypotenuse and we have a side opposite of 25 degrees, so that's the opposite. And with opposite hypotenuse, we use sine. So we have sine of 25 degrees equals 40 out of z, because z is the hypotenuse. So we have to solve for z. We can multiply both sides of the equation by z, and then we'll get z sine 25 equals 40. Then we have to divide by sine 25, and we get z equals 40 divided by sine 25. So we're going to do that in the calculator. 40 divided by sine 25. That will give me 94.7. Sorry, 94.6. 94.6 centimeters. Okay, next we're going to do this example here. It's a two-step problem because first we have to find this side length, and then we can use this triangle to find E. So to find x first, well, let me write it SOHCAHTOA first. So to get x, we have in this triangle, we have opposite and hypotenuse, so we're going to use sine. So sine 30, let's write it over here, sine 35 equals x out of 4.5. So then we multiply both sides by 4.5. And we get x equals 4.5 sine 35. Okay, and I'm going to do that on the calculator. 4.5 sine 35. Okay, and that's about 2.58. Now actually I want maybe more digits here, or to use this number on the calculator for the next step to get it to be the most accurate. So maybe I'll even write 109 as well to make it more accurate. Next step, I'm going to do, I have 60 degrees here, and we have in this triangle, this is opposite and hypotenuse, and this side is adjacent to 60 degrees. Okay, so we have adjacent and hypotenuse here, so we're going to use cosine. So cosine 60 degrees equals x out of E. So cosine 60 degrees equals 2.58109 divided by E. So to solve this one, we're going to multiply both sides by E, and then we're going to divide by cosine 60. So we're going to divide by cosine 60. So we're going to get E equals 2.58109 divided by cosine 60. So rather than typing out 2.58109, I'm going to use the number on my calculator, and I'm just going to press divide and then cosine 60. And we get 5.16, so E is about 5.16 centimeters.